Muscle wasting, or what is clinically referred to as muscle atrophy, is not just a concern for elite athletes or aging populations. It's something that can affect nearly everyone, those recovering from injury, people who are sedentary due to lifestyle or occupation, individuals under high psychological stress, or even people trying to lose weight too rapidly. Muscle tissue is metabolically expensive for the body to maintain, so when the system senses a reduction in mechanical load, nutrient intake, or anabolic signaling, it will begin to down-regulate muscle protein synthesis and upregulate muscle protein breakdown. In simple terms, your body starts eating away at your own muscle. But what if I told you that the trajectory of muscle loss, even in high-risk scenarios, can be dramatically altered with the addition of a single nutrient? And no, we're not talking about a synthetic compound or a pharmaceutical intervention. We're talking about a naturally occurring essential amino acid that most people unknowingly underconsume, particularly during the times they need it most. This nutrient is leucine, a branched chain amino acid that functions not only as a building block of protein, but more importantly, as a molecular trigger that activates the machinery responsible for muscle growth and maintenance. The reason this is so critical is that muscle protein synthesis and breakdown are in a constant state of flux. The net balance between these two processes determines whether you gain, maintain, or lose muscle mass. Leucine acts like a switch that flips the balance in favor of synthesis. It binds to sensors inside the muscle cell that activate the MTR pathway, short for mechanistic target of rapamycin. This is a highly conserved signaling pathway that regulates cell growth, nutrient sensing, and anabolic metabolism. When activated, it leads to the translation of mRNA into new muscle proteins. Without sufficient leucine, this pathway remains largely dormant, even if you're consuming enough total protein or engaging in resistance training. Now, it's important to understand that the body doesn't store leucine. It's an essential amino acid, which means it must be consumed through diet or supplementation. If it's not consistently present in your meals, particularly around the times your muscles are most responsive, you miss the opportunity to stimulate the anabolic response. And this has cumulative consequences. A few missed anabolic windows might not seem like a big deal, but over weeks or months, the net result is measurable muscle loss, decreased strength, reduced metabolic function, and compromised glucose regulation. In fact, studies have shown that in just 14 days of reduced activity or inadequate nutrition, individuals can lose up to 5% of their muscle mass. That might not sound like a lot on paper, but functionally, it's the difference between maintaining metabolic flexibility and becoming insulin resistant. It's the difference between recovering quickly from a workout or injury and developing chronic fatigue, pain, or weakness. What these studies also reveal is that when individuals consume 3 to 5 grams of leucine per day, strategically timed around meals and training, muscle protein synthesis not only remains elevated, but markers of muscle breakdown are significantly reduced. Leucine's effect isn't just about building muscle after workouts, it's about preserving muscle during periods when the body would otherwise break it down. This includes times of caloric restriction, illness, aging, or even psychological stress. Each of these states increases cortisol, the stress hormone which accelerates catabolism, essentially the breakdown of muscle tissue. Leucine blunts this response by stimulating an opposing cascade of anabolic signals, particularly through mTOR activation, which overrides the catabolic signals driven by cortisol and inflammatory cytokines. So, what are the practical ways to implement this knowledge? The first step is understanding the leucine content in different protein sources. Animal-based proteins tend to be the most leucine-dense. Whey protein, for example, contains approximately 2.5 grams of leucine per 25-gram serving. That means just one scoop of whey protein isolate post-workout can bring you near the threshold required to fully activate MTR. Eggs, chicken, beef, and fish are also excellent sources. For individuals following a plant-based diet, it becomes more nuanced. Plant proteins typically contain lower concentrations of leucine, so you either need to consume larger portions or consider supplementing with isolated leucine to reach the same effective dose. Timing is also key. The body is most sensitive to anabolic signals immediately following resistance training. During this post-exercise window, roughly 30 to 60 minutes, the muscle cell is primed to absorb amino acids, especially leucine. Consuming a leucine-rich source during this period can amplify the training effect, leading to greater gains in strength, hypertrophy, and recovery. The second most critical window is breakfast, particularly after an overnight fast. The body has gone 8 to 12 hours without food, and muscle protein breakdown has likely increased. A high, loosen meal early in the day re-establishes an anabolic environment and prevents continued catabolism. Another layer to consider is age. As we get older, our muscles become less sensitive to anabolic stimuli. This phenomenon, known as anabolic resistance, means that the same dose of protein or leucine that triggers a robust muscle building response in a 25-year-old may be insufficient in someone who is 55 or older. The solution isn't simply to eat more total protein, but to ensure that each meal contains a high enough dose of leucine to cross the activation threshold. For many older adults, this means aiming for 4 to 5 grams of leucine per meal. That might translate into 30 to 40 grams of high-quality protein or a combination of whole food and supplemental sources. For people dealing with muscle wasting due to illness or immobilization, such as during recovery from surgery, injury, or chronic disease, the stakes are even higher. Loss of muscle mass in these contexts is not just a cosmetic or performance issue. It directly impacts survival rates, recovery speed, and quality of life. In these scenarios, leucine supplementation has been shown to help maintain nitrogen balance, reduce inflammatory markers, and preserve functional capacity. Even in patients confined to bed rest, the inclusion of leucine-rich formulas has slowed or even halted muscle degradation compared to control groups receiving standard nutritional support. Leucine is not a magic bullet, but it is a powerful tool, especially when combined with resistance exercise, sleep optimization, and consistent daily protein intake. The science around its role in muscle metabolism is robust and reproducible, and unlike many other supplements that promise exaggerated outcomes, leucine's effects are grounded in measurable changes in gene expression, muscle protein synthesis rates, and functional performance metrics. We're talking about actual shifts at the cellular level that influence how your body repairs tissue, regulates hormones, and maintains energy metabolism. When designing a nutritional strategy around leucine, it's important to individualize the approach based on lifestyle, activity level, age, and dietary preferences. For a young, active individual doing resistance training several times a week, ensuring a post-workout shake with 2.5 to 3 grams of leucine is often enough to sustain positive muscle adaptations. For older adults or those in rehabilitation, each meal should be structured to provide not just total protein, but sufficient leucine to drive the anabolic response. That means looking beyond just hitting a protein target and evaluating the quality and composition of the protein being consumed. There's also a neural component that makes leucine particularly interesting. Leucine crosses the blood-brain barrier and has been implicated in the regulation of hypothalamic pathways involved in energy balance. In some studies, leucine has been shown to influence satiety, suggesting that it may help regulate appetite and energy intake, which can be beneficial in body composition strategies that involve fat loss without sacrificing lean mass. Moreover, since muscle tissue is the largest reservoir for glucose disposal in the body, maintaining it through leucine-activated protein synthesis helps sustain insulin sensitivity and metabolic health, reducing the risk for type 2 diabetes, cardiovascular disease, and obesity-related inflammation. Every individual, regardless of age or fitness level, stands to benefit from protecting and building their muscle mass. And in the landscape of nutrients that can support this goal, leucine stands out not just for its structural role, but for its unique ability to act as a signal, a message to the body that it is time to grow, recover, and resist breakdown. The biological systems that maintain muscle tissue are complex and multifaceted, but leucine is one of the few nutrients that has been shown to interact with these systems both directly and effectively. When consumed at the right times, in the right amounts, and through the right sources, it becomes a foundational part of any strategy aimed at stopping muscle wasting and promoting long-term functional strength. This signaling role of leucine is what sets it apart from other amino acids. While all essential amino acids contribute to building proteins, leucine is the one that initiates the process. It tells the muscle cell that enough building blocks are present to begin the energy-intensive process of synthesizing new muscle tissue. Without this initial signal, even in the presence of adequate protein, the muscle may not engage in growth or repair. This is especially important during times of physical stress or limited movement, such as during illness, travel, or injury recovery when the body prioritizes survival and energy conservation over tissue building. In these contexts, ensuring the presence of leucine can mean the difference between maintaining lean mass or losing it rapidly. Muscle wasting isn't just about appearance or strength. It has deep systemic consequences. Muscle tissue serves as an endocrine organ, releasing myokines that influence brain function, immune health, and inflammation. Loss of muscle mass is associated with an increased risk of insulin resistance, metabolic syndrome, and frailty. In older adults, it directly correlates with increased mortality. When muscle tissue diminishes, the body becomes less resilient. It loses its ability to stabilize joints, regulate blood sugar, and support the immune response. That's why the process of protecting and stimulating muscle tissue should begin well before visible signs of muscle loss appear. Another important consideration is the frequency of leucine intake. Muscles don't stay in an anabolic state all day. Protein synthesis rates rise and fall, and each spike in leucine initiates a new wave of synthesis. For optimal results, this signal should be triggered multiple times per day. Research suggests that muscle protein synthesis is maximized when leucine is consumed every 3 to 5 hours, ideally in conjunction with a full spectrum of essential amino acids. This supports the idea of distributing protein, and specifically leucine-rich protein, across 3 to 4 meals per day rather than concentrating it into one large serving. It's also essential to recognize that different protein sources have different rates of digestion and absorption. Whey protein is considered a fast digesting protein, meaning that it floods the bloodstream with amino acids quickly, making it ideal for post-exercise consumption. Casein, by contrast, digests more slowly, making it beneficial before long fasting periods like sleep. When consumed at night, casein provides a sustained release of amino acids over several hours, which helps maintain muscle protein synthesis during sleep and can reduce overnight muscle breakdown. For people aiming to protect muscle mass during periods of inactivity or caloric deficit, combining different protein types or layering fast and slow digesting sources can optimize the availability of leucine throughout the day and night. In practical terms, this might mean starting the day with eggs and Greek yogurt, supplementing with whey protein after training, having a leucine-rich lunch centered around lean meats or tofu, and ending the day with casein or a protein-dense meal. For vegetarians or vegans, it becomes more critical to combine plant proteins to achieve a complete amino acid profile and to consider leucine-specific supplementation. This can be achieved with fermented leucine powders derived from plant sources, which are widely available and bioidentical to the leucine found in animal proteins. Let's also address the role of exercise, particularly resistance training, in this equation. While leucine can activate the mTOR pathway on its own, its effects are dramatically enhanced when combined with mechanical tension on the muscle. Resistance training increases muscle sensitivity to amino acids for up to 24 hours post-workout, creating a window of opportunity for leucine to exert its full anabolic potential. This synergy means that even sub-optimal doses of leucine may become more effective when consumed in close proximity to training. It also underscores the importance of not just focusing on diet alone, but integrating intelligent training protocols into any muscle preservation strategy. The effect of leucine is not confined to strength training alone. Endurance athletes also benefit from leucine supplementation, particularly in multi-hour events or during periods of high training volume. Endurance exercise induces a different kind of muscle stress, one that can lead to muscle protein breakdown through energy depletion and oxidative stress. In this context, leucine helps blunt muscle degradation and accelerates recovery by promoting repair of damaged fibers. It supports mitochondrial health and energy metabolism by encouraging the synthesis of enzymes involved in cellular respiration. Athletes in sports like cycling, long distance running, or rowing often overlook the importance of muscle maintenance because the primary goal is endurance, not hypertrophy. But muscle loss in these populations can impair performance, increase injury risk, and lead to overtraining syndromes if not proactively addressed. In clinical settings, leucine has been used to support individuals with conditions like cancer cachexia, chronic kidney disease, and immobilization due to hospitalization. In these populations, rapid muscle wasting is a common and dangerous side effect. Supplementation with leucine-enriched amino acid mixtures has been shown to slow or even reverse muscle loss, particularly when combined with physiotherapy or light resistance training. The mechanism remains the same. Leucine stimulates mTOR, and mTOR increases muscle protein synthesis. But in clinical populations, the outcome is more than physical. It can be the determining factor between functional independence and long-term disability. When evaluating how much leucine is needed, it's useful to understand that the optimal dose is not linear. There's a threshold effect. Below a certain levels, typically 2 to 3 grams per serving in younger individuals and 3.5 to 5 grams in older adults, mTOR is not sufficiently activated, and muscle protein synthesis is minimal. Once this threshold is crossed, synthesis increases significantly, but then plateaus. Taking excessive leucine beyond that point doesn't produce proportionally greater results and may lead to metabolic strain if other nutrients are lacking. This is why dosage precision is more important than simply taking more. Balance matters. Another factor that influences leucine effectiveness is insulin. While leucine alone can activate mTOR, insulin also plays a supporting role in muscle protein synthesis by increasing cellular uptake of amino acids. Consuming leucine in combination with a small amount of carbohydrate post-exercise can help enhance this insulin response, further increasing muscle building outcomes. This doesn't mean consuming large amounts of sugar, but even 20 to 30 grams of a fast digesting carbohydrate like fruit or rice can be enough to synergize with leucine and support recovery. Sleep and circadian rhythm also impact how the body responds to leucine. Sleep deprivation impairs mTOR signaling and increases cortisol, making it harder for the body to enter an anabolic state. Poor sleep also reduces testosterone and growth hormone levels, 2 hormones deeply involved in muscle metabolism. Ensuring 7 to 9 hours of quality sleep enhances the body's responsiveness to leucine and protein intake. This highlights the importance of not viewing leucine or any nutrient in isolation, but as part of an integrated system that includes training, recovery, and lifestyle management. Hydration status is another overlooked factor. Muscle is composed of over 70% water, and dehydration reduces blood flow, impairs nutrient delivery, and diminishes performance in both strength and endurance contexts. Amino acid transporters in muscle cells rely on proper fluid balance to function optimally. Without adequate hydration, even a perfectly timed dose of leucine might be less effective because it won't reach the muscle cells efficiently. Consistently drinking enough water, especially around training sessions and meals, ensures that nutrient delivery systems are functioning at full capacity. Genetics also influence the body's response to leucine, particularly through variations in the genes encoding components of the mTOR pathway or amino acid transporters. Some individuals are naturally more responsive to anabolic stimuli, while others require more targeted intervention. However, lifestyle and behavior consistently override genetic predisposition. Even individuals with a lower baseline sensitivity to anabolic stimuli can build and maintain muscle through strategic use of leucine, resistance training, and supportive recovery habits. There's also a psychological dimension to maintaining muscle health. Regular resistance training and nutrient timing don't just build muscle, they reinforce discipline, resilience, and a sense of control over the body. The process of understanding how nutrients like leucine affect your physiology deepens your relationship with food, training, and recovery. It transforms eating from a passive act of consumption into a tool for biological precision. It gives you agency. That psychological reinforcement is critical, particularly in periods of stress, aging, or recovery when motivation might be lower and biological inertia might be pulling you in the opposite direction. Ultimately, muscle is not just tissue, it's a living system that responds to input, both mechanical and nutritional. It adapts, but it also deteriorates when left unattended. The knowledge that a single nutrient, when timed and dosed correctly, can significantly tilt the balance in favor of muscle maintenance is both empowering and actionable. And while leucine is only one part of the larger anabolic equation, its unique signaling role makes it the linchpin in any effective muscle preservation strategy. Leucine's importance also becomes especially evident when examining how the body responds to injury or extended periods of immobility. Consider a person who has broken a leg and is required to use crutches or remain largely inactive for several weeks. Even in young, otherwise healthy individuals, the body will begin to reallocate resources. The unused limb experiences a rapid decline in muscle cross-sectional area, strength, and metabolic activity. This happens not simply because of lack of movement, but also because anabolic signaling is suppressed in the absence of mechanical load. In this state, dietary interventions become one of the only tools available to counteract the atrophic effects of disuse. Ensuring adequate protein intake is foundational, but ensuring sufficient leucine intake is essential. It provides a signal to the muscle cells that even in the absence of movement, the body still values the maintenance of muscle tissue. The application of leucine in recovery from surgery is another area where science and clinical practice align. Post-operative muscle loss is a major concern, especially in procedures involving the hip, knee, or spine. Many patients experience declines in muscle mass and function that never fully recover. Pre-habilitation strategies, which involve preparing the body nutritionally and physically before surgery, now often include leucine supplementation as a standard component. The idea is simple. Enter surgery with a higher level of muscle mass and anabolic activity, which improves recovery outcomes, reduces hospital stays, and restores function faster. This again highlights leucine's role not just in building muscle, but in preserving it under stress. Another dimension to leucine's effects lies in its influence on satellite cells, the stem-like cells responsible for muscle regeneration. These cells become activated in response to muscle damage, especially following intense resistance training or injury. Once activated, they proliferate and fuse with existing muscle fibers, donating their nuclei and contributing to muscle repair and growth. Leucine doesn't just stimulate protein synthesis, it also supports satellite cell activity and proliferation. This means that recovery isn't just faster, it's also more complete with long-term structural adaptations that fortify the muscle against future stressors. In a performance context, this translates to improved recovery times, less soreness, and greater gains from each training session. For athletes training multiple times per week, or even multiple times per day, this efficiency matters. The window between sessions becomes a critical time to repair, reload, and stimulate anabolic processes. Leucine, especially when paired with fast-acting protein and supporting micronutrients like magnesium, zinc, and vitamin D, enhances this regenerative cycle. Athletes who understand this not only train harder but also train smarter, leveraging the body's natural rhythms and biochemistry to optimize performance outcomes. Moreover, the emerging field of chrononutrition, how the timing of food intake influences health, adds another layer to the leucine discussion. Muscle tissue, like many organs, follows a circadian rhythm. Certain times of day are more conducive to protein synthesis, while others favor maintenance or breakdown. Morning, especially following an overnight fast, presents a unique anabolic window. If missed, the muscle may spend several hours in a catabolic state, progressively losing mass. A leucine-rich breakfast is one of the simplest and most effective strategies to break this cycle and shift the muscle into an anabolic gear early in the day. Pairing leucine with quality sleep and morning sunlight can create a powerful feedback loop that reinforces circadian alignment and enhances long-term muscle maintenance. On the molecular level, there's an increasing interest in how leucine affects mitochondrial function. The mitochondria are the energy-producing organelles within cells, and they play a vital role in muscle performance, fatigue resistance, and metabolic regulation. Leucine has been shown to activate signaling pathways that upregulate mitochondrial biogenesis, the creation of new mitochondria. This includes activation of the PGC1 alpha pathway, a master regulator of mitochondrial gene expression. This is important because healthier, more abundant mitochondria increase energy efficiency and endurance capacity. This suggests that leucine supplementation isn't just useful for hypertrophy, but also for improving aerobic metabolism, stamina, and overall cellular health. The cognitive effects of leucine, while less well known, are also emerging as an area of interest. Because leucine can cross the blood-brain barrier, it may have an influence on brain function and mood, especially in the context of exercise recovery. Some preliminary studies suggest that branched-chain amino acids, including leucine, may help modulate serotonin production during prolonged exercise, potentially delaying central fatigue and preserving mental sharpness. This has important implications for both athletic performance and general mental well-being, especially in individuals under chronic stress or sleep deprivation, where neurotransmitter balance can be disrupted. Another promising avenue is leucine's potential role in immunomodulation. The immune system, like the muscular system, is highly dependent on protein turnover. Immune cells rapidly proliferate and differentiate in response to infection or injury, and this process requires not just total protein, but specific amino acids. Leucine appears to support the activity of T cells and natural killer cells, which are vital components of innate immunity. This immune support becomes crucial during high stress periods, such as intensive training, travel, or illness, when the risk of immune suppression is elevated. Protecting both muscle and immune function with one targeted nutrient adds efficiency to any health optimization strategy. There's also a role for leucine in combating the muscle depleting effects of chronic inflammation. Inflammatory cytokines like TNF-alpha and IL-6 promote protein breakdown and suppress protein synthesis. This is a common problem in conditions like rheumatoid arthritis, cancer, or even in low-grade systemic inflammation associated with poor diet and metabolic syndrome. Leucine, through its mTOR activating properties, can partially counteract these effects. Moreover, it may help modulate the activity of the NF-κB pathway, a major regulator of inflammatory gene expression. This dual action, stimulating muscle synthesis while reducing inflammation, positions leucine as a powerful tool in managing both acute and chronic catabolic conditions. The economics of leucine intake are also worth mentioning. Unlike pharmaceutical interventions, leucine is affordable, widely available, and well tolerated. It has a strong safety profile even at doses above the typical dietary intake. This makes it accessible not just to elite athletes or clinical populations, but to anyone seeking to preserve or build muscle as part of a long-term health plan. The barrier to entry is low and the science behind it is well established. From a public health standpoint, encouraging higher intake of leucine, rich foods, or even modest supplementation could reduce the burden of sarcopenia, frailty, and metabolic disease across the population. For those interested in measuring the effectiveness of their leucine protocol, there are several practical markers to monitor. Strength gains, lean mass retention, and reduced post-workout soreness are obvious physical indicators. But more advanced metrics include changes in fasting insulin, glucose variability, and resting metabolic rate. Improvements in these areas suggest that the muscle tissue is not only being preserved, but is actively contributing to systemic metabolic health. Wearable technology can also assist, providing real-time data on recovery, sleep quality, and heart rate variability, all of which reflect the body's anabolic or catabolic state. Ultimately, incorporating leucine into your daily routine doesn't require drastic changes. It requires precision and consistency. Knowing the leucine content of your meals, timing your intake around training, and supporting your nutrition with sleep, hydration, and stress management forms a feedback system that promotes sustained muscle integrity. Whether you're aiming for peak athletic performance, recovering from injury, or simply trying to age well, leucine is a key variable in the equation. The integration of this nutrient into a comprehensive lifestyle framework creates a biochemical environment where muscle is valued, preserved, and allowed to thrive, regardless of external stressors or internal shifts over time. In summary, the preservation and growth of muscle tissue is not just about lifting weights or consuming large amounts of protein. It is about precision, timing, and targeting key biological pathways. Leucine stands out as a powerful nutrient that acts as both a building block and a signal to initiate muscle protein synthesis. Its unique ability to activate the mTOR pathway makes it indispensable in preventing muscle wasting, enhancing recovery, and promoting longevity. When incorporated strategically through leucine-rich meals, supplementation, and synergistic training, this single amino acid can shift the body from a state of breakdown to one of growth and repair. Whether you are recovering from injury, optimizing performance, or simply striving for better health across the lifespan, leucine offers a scientifically grounded, accessible, and highly effective tool to stop muscle wasting and build lasting resilience.